Welcome to the Deep Dive. We're here to cut through the noise and get you straight to the core insights from, well, the latest research.
That's the plan.
And today, we're tackling something that's moving incredibly fast. AI advancements. I mean, everyone feels it, right? AI is getting better.
Mhm.
But how do we actually measure its progress on, real stuff, not just the usual benchmarks?
Yeah, that's a really crucial question, and it's pretty much exactly what we're going to get into today. We're looking at a pretty groundbreaking new metric, actually.
Metric. Okay.
Yeah, one that helps us quantify AI capabilities in a way that's much more intuitive.
Okay, I'm intrigued. So this metric is called the 50% task completion time horizon. Bit of a mouthful, but the idea is simple.
Basically, yeah, it looks at the time it typically takes a human to do a task,
Okay.
and then measures if an AI can do that same task with a 50% success rate. So it's a direct comparison, AI versus human, but based on time.
Got it. So our mission today is to really unpack this measure, understand how fast it's growing, and apparently it's growing fast, and figure out what that means for, well, everything, work, the future.
Exactly. And we're basing this on a really fascinating new research paper. It uses a ton of data analyzing AI models from 2019 right up to, basically now 2025.
All right, let's dig in then. This time horizon metric.
Yeah.
What makes it so different, so valuable compared to, say, the benchmarks we usually hear about?
Well, that's a great place to start. The traditional benchmarks, they have some real limits.
Like what?
Often they use kind of artificial tasks, right? Or tasks specifically picked to be hard for current AI, which can skew things. Adversarially selected, they call it.
Yeah.
Plus, benchmarks tend to saturate. A task becomes too easy for newer models, so you can't really compare, say, GPT-2 from back in the day with the frontier models we have now. It's like comparing apples and oranges.
Right, you lose that long-term perspective. It sounds like trying to measure, I don't know, a Formula One car and a regular car on the same tiny go-kart track doesn't really tell you much about real-world driving.
That's a great analogy, actually.
Yeah.
And that's the power of this new metric. The 50% time horizon gives you something intuitive, something quantitative, grounded in human time. It's about what AI can do, measured against how long it takes us.
Makes sense. So what kind of tasks are we actually talking about here? How do they gather all this data?
So they used a really diverse set, about 170 tasks in total.
170. Wow.
Yeah, it's pretty comprehensive. They pulled from a few places. HCAST, which has 97 tasks covering cybersecurity, ML, software engineering, general reasoning, tasks ranging from like 1 minute to 30 hours long.
30 hours. Okay, that's serious.
Then there's RV Bench, that's 7 really tough ML research engineering tasks, each taking humans about 8 hours.
Okay.
And a new one called Softway Software Atomic Actions. These are novel, much shorter tasks, like 1 to 30 seconds. Think single steps in coding.
So a real mix of quick actions and long, complex projects.
Exactly. The breadth is key. It means the findings aren't just tied to one specific type of task.
And the human side, how did they get the baseline times?
They timed actual skilled professionals doing these tasks. Folks with, on average, 5 years experience, many from top universities.
Real experts.
Right. They collected over 800 human baselines. That adds up to more than 2,500 hours of human work timed. That gives you the human time for each task.
Okay, so you have the human times, then they tested the AIs.
Yep. 13 frontier models, the big names released between 2019 and 2025. They ran them on the same tasks.
And what did they find when they put the human times next to the AI success rates? Any surprises?
Yeah, this is really interesting. They found a very strong negative correlation, like a really clear inverse link. Meaning tasks that take humans longer are generally harder for AI models to succeed on. The relationship was quite strong, R squared around 0.83.
Okay, that feels intuitive, but it's good they quantified it.
Exactly. And the whole approach is kind of clever. Inspired by psychometrics, how they measure human abilities, modeling task difficulty against the AI's chance of success.
Okay, so the metric is set up, the data is in. What was the big reveal? When they applied this time horizon metric, how fast is AI capability actually growing?
This is where it gets pretty mind-blowing, honestly.
Okay.
Right now, the frontier models, think like Claude 3.7 Sonnet, they have a 50% time horizon of around 50 minutes.
Meaning they can nail tasks half the time that take a skilled human about 50 minutes.
Exactly. But here's the headline finding, that time horizon. It's been doubling approximately every 7 months since 2019.
Doubling every 7 months.
Yep. Exponential growth. Really,
Yeah.
really fast.
Wow. Okay, can you put that in perspective? What did it look like back in 2019 versus now?
Sure. So back in 2019, early models like GPT-2 or even early GPT-3 like DaVinci 002, they basically failed almost everything that took longer than a minute.
Okay, pretty limited.
Very. Then jump to 2023. Models like GPT-4, Claude 3 Opus, they could start handling the easier HTAST tasks. Their time horizons were maybe in the 5 to 30-minute range.
Better, but still relatively short tasks.
Right. But now, the latest models, like O1 or Claude 3.7 Sonnet, they're completing some tasks that take the human experts over 4 hours.
4 hours? That's a huge leap in just a couple of years.
It's a massive jump. The progress is just stark when you look at it this way.
So what's driving that? Is it just that the models are bigger? Or is something else changing?
It's definitely more than just size, though that plays a part.
Yeah.
A big factor seems to be reliability and adaptability, especially adapting to mistakes.
How so?
Older models, even some GPT-4 versions, would often get stuck repeating the same failed action over and over.
Right, I've seen that.
Yeah.
Frustrating.
Yeah. The newer models, like O1 they mentioned, are much better at recognizing a failure and trying something different. They just don't repeat mistakes as much.
Okay. Better error correction. What else?
Enhanced logical reasoning seems to be part of it, and crucially, much better tool use. Older models might mess up the syntax for calling a tool or using a command,
Right.
whereas newer ones are more adept at, say, editing files correctly or using tools effectively as part of the task.
Okay, so they're becoming more reliable, better reasoners, better tool users. But are they perfect? Are there still things AI agents just aren't good at?
Oh, absolutely. Yes, definitely.
Okay.
Even with these big leaps, they still struggle quite a bit with what the researchers call messier tasks.
Messier. What does that mean?
Tasks that don't have really clear feedback loops, or tasks where the AI needs to be more proactive, like seeking out information itself.
Can you give an example?
Sure. Like instead of just guessing API endpoints, a human might go read the documentation first.
Right.
AI agents might still just try guessing. Or, say, needing to figure out a file's encoding. A human might use a file command to check. The AI might just try decoding it different ways until one works, which is inefficient.
So lacking some common sense or investigative initiative?
Kind of. And interestingly, they noted that for O1, half of its failures came from just giving up too soon. Premature task abandonment.
Ah. So they're good at adapting when they know they made a mistake, but maybe not great at exploring or persevering through ambiguity.
That seems to be a fair summary of the current limitations, yeah.
Okay, so let's connect the dots. This exponential growth is stunning, but you mentioned these messy tasks. How much do these findings really apply to the complex, often quite messy jobs in the real world?
That's the million-dollar question, right? External validity. And the researchers dug into this. They acknowledged that their benchmark tasks, even being diverse, aren't exactly like real-world knowledge work.
Right. Real work is messier.
Exactly. They actually identified 16 messiness factors, things like being short on resources, facing totally new situations, working in environments that change.
Yeah.
Stuff that makes real tasks harder.
And what did they find? Does messiness trip up AI?
Yes, it does. They confirmed that AI agents perform worse on the tasks rated as more messy. No big surprise there.
Okay, so that might temper the excitement a bit. Does it mean AI progress might hit a wall when it comes to real-world complexity?
Well, here's the really crucial part. While performance is lower on messy tasks, the rate of improvement over time was basically the same for both the less messy and the more messy tasks.
Wait, really? So they're getting better at the messy stuff just as fast as the cleaner stuff?
That's what the data suggests. There was no sign of progress slowing down specifically for the harder, messier tasks. It seems the improvements are lifting all boats, so to speak.
That's actually pretty significant. Did they try to verify this using any standard industry tests?
They did. They ran their whole methodology on SW Bench Verified. That's a well-known benchmark for software engineering tasks.
Same trend.
Pretty much, yeah. A similar exponential trend. Interestingly, the doubling time looked even shorter there, maybe around 70 days.
Faster. Why would it be faster?
There's a potential explanation, a nuance. The original human time estimates for SW Bench might have been based more on experienced maintainers who know the code already. This could mean those times underestimated how long easier tasks would take someone with less context, like a contractor. If the baseline for easy tasks was too fast, it could make the AI's progress look steeper than it really is relative to a low-context human.
Ah, I see. The baseline you compare against is absolutely critical. It shapes how you perceive the speed of progress. Did they look at actual, like, real software issues, not just benchmarks?
Yes, briefly. They did a small experiment using real internal pull requests, actual software bugs, and feature requests from their own work.
Oh, okay. Now that's getting really close to the real world. What happened there?
This was fascinating. They found that human contractors people hired externally, less familiar with the code base, took way longer, like 5 to 18 times longer, to fix these issues compared to the maintainers who worked on that code daily.
Wow, that's a huge difference. Context matters a lot.
Exactly. It shows the massive value of familiarity and existing knowledge.
So how did the AI do? Did it perform like the super fast maintainer or the slower contractor?
It performed much more like the contractor. The AI's success rate and implied time horizon lined up with the time it took the lower context human contractors, not the super fast maintainers.
That's a really insightful finding. It suggests current AI is maybe more like a competent new hire who needs to learn the ropes rather than an experienced team member.
That seems to be a good analogy for its current capability level on these kinds of tasks, yeah.
So wrapping up this section, what are the main caveats we need to keep front of mind when we think about these results?
Well, it's important to remember the context of the benchmarks. Many tasks had automatic scoring, which isn't always realistic. There wasn't much interaction with other agents or humans needed. Resource limits were often relaxed. A single mistake wasn't always fatal, and the environments were generally static, not changing unpredictably.
Right. Real life isn't usually that neat.
Exactly. So these differences mean you can't just take that doubling every 7 months figure and apply it blindly to every single real-world job task. Caution is needed. But the underlying trend, that consistent exponential improvement across different kinds of tasks, even the messier ones, and aligning with low-context human performance, that seems pretty robust and significant.
Okay. So if we take that trend seriously and try to look ahead, what does this exponential growth suggest about AI capabilities in the, say, next few years?
The researchers actually picked a specific milestone to think about, a 1-month time horizon.
1 month, meaning AI could handle tasks that currently take a skilled human about a month of work.
Roughly, yeah. Around 167 working hours. They chose that because, well, an AI capable of tasks that long could potentially start doing things like onboarding onto a complex project, acquiring context like a human employee.
Generating real economic value independently.
Maybe even making novel scientific discoveries. It feels like a threshold for a different kind of capability.
Okay, that's definitely a significant milestone. So based on the trend they observed, when might AI reach that 1 month horizon?
Okay, so if you just naively extrapolate the trend, they saw that doubling every 7 months.
Yeah.
It predicts that AI systems capable of automating those month-long software tasks could arrive somewhere between late 2028 and early 2031.
Late 2028 to early 2031. That's really soon. That's only a few years away.
It is startlingly close.
Yeah.
And they add that even if their absolute time measurements are off by a whole factor of 10, which is a huge margin of error,
Right.
the trend still suggests AI capable of multi-day or multi-week tasks is likely less than a decade away. The sheer pace is the main story here.
That really puts it into perspective. What could speed this up or slow it down? What factors influence that future trajectory?
Several things. Continued progress in agency research, making AI better at planning and executing long sequences of actions that could definitely accelerate the trend.
Making them better project managers, essentially?
In a way, yeah. On the flip side, hitting limits on, say, compute power could slow things down.
Not.
But historically, algorithmic improvements have often found ways around compute limits, making AI more efficient. So it's not a guaranteed slowdown.
Okay. And what about the idea of AI helping to build better AI?
Ah, yes. That's the potential game changer. If AI systems get good enough to actually substitute for human AI researchers, or if they can significantly improve their own training processes.
And the rate of progress itself could accelerate.
Exactly. It could shorten that timeline to the 1 month horizon, potentially quite dramatically. It introduces a kind of positive feedback loop.
And thinking even further out, what about AGI, artificial general intelligence? How does that fit into this time horizon idea?
Well, if we ever reached AGI, an AI that could genuinely do pretty much any intellectual task a human expert can, with similar success, its time horizon would essentially become infinite. It could tackle tasks of arbitrary length. In that scenario, the trend wouldn't just be exponential anymore. It would become faster than exponential, heading towards an asymptote, basically a vertical line, around the date AGI arrives.
Wow. Okay, that's a very powerful way to think about the potential endpoint.
It really frames the potential scale of change we might be looking at.
All right. So to recap today's deep dive, we've explored this really powerful new metric, the 50% task completion time horizon. It gives us a much more intuitive, human-grounded way to measure AI progress. And the main finding is pretty staggering. AI's capability, measured this way, seems to be doubling roughly every 7 months.
Yeah, an incredibly rapid exponential growth trend since 2019. We saw how models have gone from struggling with one-minute tasks to tackling multi-hour tasks in just a few years.
And while we need to be careful about applying this directly to all the messy complexities of real-world jobs,
Right, the caveats about task structure, context, and messiness are important. Current AI seems more like a capable but low-context new hire.
the fundamental trend of improvement seems undeniable. It's consistent across different task types, even the messier ones.
Exactly, which suggests a future perhaps only a few years away, where AI systems could be automating software development tasks that currently take humans weeks or even a month.
It definitely paints a vivid picture of the near future. So, for you listening, what really stands out to you about how quickly AI capabilities seem to be expanding? And maybe more importantly, what do you think that means for the kinds of work, the kinds of tasks you might be doing in just a few years?
Definitely something to think about.
Something to mull over until our next deep dive.